Is going. Hello, welcome. Happy Monday. Mondays. We have fought and overcome technical difficulties and internet issues, but we are here online. Week 6 is a fun week. It's a lot. If you look at the media sets, it's like 16 different individual things. And there's a lot of code too. There's a lot of labs for this, but they all go by super fast. And I think it's a good palate cleanser after the modeling and pretty intensive machine learning, data wrangling introductions that we covered last week. So big ideas to take away for Module 6, Introduction to Data Visualization. Why is data visualization important? What are the different types of data viz? How do we use data viz for storytelling on real world data sets? And then how do we move from what I call static reports or static visualizations into kind of the world of interactive reports? So we'll do a little bit of history, we'll do a little bit of demo, and then we'll end by working on the final, I think 613 little project here. Everything, all these labs and everything we'll cover has been already run and backed up by me as well on my GitHub. So if you have questions about any of the code or topics, feel free to just check that out on your own time. All right, so quick history, and then I'll dive into some of the code. Data viz has been around a long, long time. And the principles of creating good dashboards and good visualizations have been well thought out and discussed over the last 20 years or so. But I like to try, throw out a couple of names here of classic visualizations that you may or may not have seen in your time. So the first is actually Napoleon's March, which I can find it. This is one of the first like well-known like really like good data visualizations, like what it shows and what it doesn't show, and how it can tell a story just with one visualization. Basically, the idea here is that this visual is just a depiction of Napoleon's invasion of Russia. And you can see that this video was actually created in the 1800s, which is pretty cool. But you can see that it started out with this huge army that went to Russia, and then they ended up the black line is the number of people that came back. So very small amount of his army made it back. But this kind of sparked a really good discourse on like best practices and visualizations. It's using color, right? Using shapes and trying to tell a full story just within a single visualization. And again, this visualization is over 200 years old, which is really cool.
And I
The other one, yeah,
sorry if I'm interrupting there, but
no, you're good.
that image there, that black line that crossing the main yellow line, is that people just quitting at that point?
So basically, the idea was that they lost. I'm not sure what this black line here represents, going from the P1 all the way back down to bar. I think that maybe yeah, maybe as they got back there, they left and went back to that hometown where they got from. But yeah, the idea is that like so many people died in his army over the winter, and trying to invade Russia is not very well recommended. And even on the march back, everyone got sick and died, even of those survivors that went into Russia. So I think it's yeah, maybe that's where they were returning from the town they were returning. But the large idea that I'm looking at is you had this large group of people that left and went into Russia, and then the slowly smaller line that gets back, as you can see, people died in Russia, in Moscow, and then got sick and passed away coming back. But yeah, the idea is like the history of some of these original data visualizations. Another one that I want to show, I know I'm going quick here, is Florence Nightingale, who I remember like reading in school. But she was a nurse during the Civil War, and she's kind of known as like the mother of data visualization and data storytelling, which is really interesting. She created this really awesome like pie chart. It's not really a pie chart, it's like a blend of like a pie chart and an area chart. Let me open this image up in a new tab. And we'll include both of these in the recording session afterwards. But this is looking at causes of mortality in the Civil War. And it's actually a really interesting graph. You can see the different times, the months of the year, and then the proportion of the different cases put on it. And the other reason why I show this is just, again, the history, putting this into perspective of data visualization and data dashboarding. The idea of reporting data in a visual medium has been around for a couple of hundred years. And with this means there's been good discussion around data visualization and data dashboarding design for those full couple hundred years, and what it means to be a good visualization and what it means to be a bad visualization. So a couple other kind of small topics here before we jump into code. First, let's discuss what it means to be a good visualization. There's a name you should know, and again, we'll include this in our notes for your extra reading, but that name is Edward Tufte. And he is one of the original, he's still alive, but he's one of the kind of pioneers of actually dictating good dashboard design. He has his own principles for data visualization that we'll share. So I can pull up what they are actually, what they look like. But yeah, one of the key ideas that you'll see is things like using color to kind of draw the eye and use color specifically and well used. The kind of idea is data to ink ratio. Let me see if I can find it. Data to ink. Basically, that as you start putting more ink on your visualization, as you start putting more stuff on it, you really want most of the ink to be representative of data, right? You want to minimize or erase as much non-data ink as possible. So ideas would be like maybe you shouldn't add just like an emoji of a cat or something under your graph because that's not really relevant and it's just taking away uh, from the idea of data ink, right? So it's a pretty compelling argument, and it's really interesting because it kind of came out from things like this from like I'm putting up Florence Nightingale's visual here. As you can see, most of the ink is fixated on data, right? The area chart, the pie chart, that's where most of the ink is being used. We only have annotations and then the white background behind it. So this also kind of goes hand in hand with things known as like chart junk. Man, uh, this is a really good visual as well. It's basically like what makes a bad visualization, and you can almost think of bad visualizations or things that go against Tufte's principles. So besides data to ink, chart junk is going to be things like excessive colors, excessive dimensionality, excessive like images that aren't really needed. And what you can actually see here is these are all inverses of the same thing. So this is what there's multiple chart junk on this one graph. So the first, let's start with the dimensions. This is a two-dimensional graph. We have like enrollment percentage and year, but our visualization is in three dimensions, which is kind of excessive and it's definitely not needed. The second is the junk, right? So what we can see here is this yellow visual is completely irrelevant because everything that it shows is actually defined in this red graph down here. And you can see that here, like this is showing 72%, but this shows 28%, right? 100 minus 72 is 28. So we don't need to know percentage of people enrolling in college is obviously going to be one minus the people that don't enroll in college. So again, idea is try and have as much signal in your visualization as possible, decrease the amount of fluff. This is typically why you also see like the 3D bar plots in Excel be hated on a lot, which is kind of funny. Like, please do not use 3D bar charts ever again. We'll get into data is ugly in a second. I like data. I'm in that subreddit pretty often. But again, the idea is like if I have a graph that is depicting two dimensions, right? Profit and time of year. I do not need to add an irrelevant third dimension to the graph, right? You're just taking away from the actual perspective of the graph itself or of the data that you're trying to show in the graph. Um, I think that's mostly the big ones. Data to ink, chart junk, and data density is interesting. Again, it's kind of go hand in hand. It's like make sure that most of the visualization is using is from the data, right? As opposed to a lot of fluff. So these are some principles that are easy to see for data is beautiful and data is ugly. And it kind of translates also into what makes a bad visualization. So what makes a bad visualization is when you start lying, kind of with your visualization, with your data, with your scales, with your axes. So you can see a couple different use cases for this. And this is going to be irrelevant of political standards. I'm just going to pull some of the famous ones. Um, Let me see. It's like I might just do Fox. I should just do Fox News. Data is ugly. Um, and again, all the political parties do the same. Looks like I can find one of the get some of the good ones. This is one of the famous ones. This is a famous image of data is ugly. So this uses a pie chart. There's a couple things kind of messed up with it. The first is that obviously it doesn't add to 100. As we start looking at this graph, you'll see that we have 70% back Palin, 60% back Romney, and 63% back Huckabee. Why are we using a pie chart for this? This makes no sense. Doesn't add up to 100. And the second is also the 3D value here. I'm not a big fan of 3D pie charts, and neither is Tufty or some of the other kind of standard visualizations. But you can see we're just straight up lying kind of with this graph. There's a couple other ones, as I can find one. There's one on oh yeah, this is a pretty funny one. This is a line chart. But the problem with it is that 7 to 9, 9 to 13, and then 13.5 to 15. This is not a linear graph, right? We shouldn't have a straight line connecting these points. We're going up by 2, going up by 4.5, going up by 1.5. And then also the month ranges aren't consistent either. December '07, September '08, March '09, June 10. Again, this doesn't actually say it's not really a good story. It doesn't say anything or do anything. So again, we're lying here with our axes as well as with the line. Let me see if it's this is another good one. This is one that's lying with scale to tell a dramatic story. So the idea here is percentage of Americans that identify as Christian, again, irregardless of your religion affiliation. But we see in 2009, it's 77%, 2019, 65%. But the way they've done the axis makes this a really dramatic story, right? It's like, oh my God, if I'm just looking at this image, I would say something like, wow, this is a huge decline, right? And it kind of is a decline of 12%. But because my axis only goes from 50, oh, I've already updated this one as well. Yeah, 4 years ago. Going from 58% to 78%. That's not what we should do. We should have the axis go from 0 to 100 to really fully see what that impact of 12% is. And sure, it's a decline, and maybe it's something that should be noted, but it's not necessarily as dramatic as this visualization is trying to tell, right? So it's some pretty interesting examples of like what's good, what is bad. This one I like this one because it goes back to the data to ink ratio. This violates the data to ink ratio because the ink, all this red, right? Oh no, the axis is upside down as well. I was like, oh my God. Yeah, this whole graph is kind of bonkers. 721 being above 873 just because the axis is backwards. All this extra shaded red that's not needed. That doesn't really help tell a compelling story, right? Doesn't tell a whole lot of interest in things. So honestly, when you lie with your data, it's typically going to be about scaling on your axes, or kind of the trends in the chart that you're trying to see. You'll also see, I got one last note on this, and then Karen, I'll probably pass it over to you. Oh yeah, the Obamacare one's pretty funny too. They have no scale at all. We have no y-axis over here. So because we have no y-axis, showing this bars of 6 million to 7 million, again, looks like, oh wow, what a crazy dramatic increase. But I don't know, if my scale was 0 to 10 million, like that's only like 1/10 of that's only a 10% increase or 10% of my total y-axis. So again, because we're lying with our y-axis, we're able to kind of over dramatize trends in the data sets. One other quick note I wanted to say, and then Karen, I'll pass over to you for a sec. The other one I wanted to bring back was pie charts. So the reason why pie charts are not used very often anymore as a data visualization is because it's so easy to lie with them. And you can kind of see this coming up here at the top. With a pie chart, a couple of problems that you have is adding everything up to 100, and that may not be intuitive for some people. And then B, let's look at this pie chart again. Back Palin 70%, back Romney 60%. But if I was to ask you which slice is bigger, the red slice or the green slice, you would probably come back and say the green slice is bigger. And that's just an issue of perspective. But this is very common with pie charts, is that as like humans, it's really difficult for us to calculate area of a pie shape and then use that to be like, oh, that is definitely bigger or smaller than some of these other values. So let me see if I can find like a good pie chart graph or a good pie chart graph. But anyway, but I'll find another one that shows that it's lying. But this is why you'll see a lot more donut charts in the world. Again, like they're still lying here because they don't add up to 100. But with a donut chart, it's typically easier to compare slices. So what I do like about this graph for the donut chart at least is 53% to 49%. But if I tell you which is bigger, the purple slice or the blue slice, you can look at this and say, oh, the purple slice is bigger, right? Even though it is only like 4%, but it does kind of look bigger. The line is kind of a little bit further down. It does look bigger than the blue slice. But if this was represented as a pie chart, it'd be much more difficult to see. Pie chart slices difficult to read. Let's see what we can find. Oh yeah, it's like something like this. It's like I'm gonna open up this. Yeah, death to pie charts. I love this. I love this blog. I share it in all my classes, so I'll make sure to share it in ours as well. But it's the same idea. If I look at this pie chart and I tell you which slice is bigger, and ignore the labels, just looking at this orange slice versus this software blue slice, which of these slices is bigger? Again, as humans, it's really difficult for us to calculate this area in our heads to be able to look at kind of what they are, especially when they're so close in their total percent, right? Or even compare the blue to the purple. To us, they look virtually identical. And when we want to share visualizations like this, we want to be able to compare and share those patterns between these different categories or these different slices. So again, this is why you'll see even on like I see commercials and ads like a lot of like drug commercials and things, and you'll see pie charts or donut charts being used instead of pie charts. And so that's really why when we move to pie chart to donut charts from a pie chart, we essentially replace these slices with curved bars, which are usually easier to see, or you could just use a regular bar chart, which makes it a lot easier for us to quickly compare. So again, this is that same pie chart data, but represented as a bar chart. And again, comparing 9 to 8, 8 to 6, it's a lot easier for us to quickly look at it and go, oh, mobile is bigger than software. And it's easier to see that kind of with a bar chart instead. I know that was a lot, Karen. I
Yeah,
was all over the place
I was
there.
going to say that last pie chart you had, um, yeah, yeah, that one. The other thing about it is like, and I'm going to say because you have an art background too, and about color. One of the reasons it's hard to distinguish that like this one and this one are so similar, like the software and the
Oh
other one
yeah.
next to the purple one, because the purple one will start to look bigger just because it's a more dominant kind of color. So we'll see it as a little bit. We'll see it more as prominent, maybe bigger than the one next to it than it should be. So that's another thing about using color really carefully to uh,
Yeah.
to not cause confusion. Uh, of course, you want to have really good contrast in colors because some people don't see as well. So you want to have good contrast. You want to have good contrast with text and colors and background. And there, it's a little hard. Some of the contrast there might not be good. Too, for the labels on the slices. They're pretty close in value. So that would be not good for someone. But yeah,
Yeah.
the bar charts, that's just like my little example I made up of Joe and Fred that I put
Yeah.
on there. It was like, I could make it look like, Joe was getting like next to nothing and Fred was getting this huge mandate when really there was only like 2 or 3%, 1 or 2% between them in the
Yeah.
actual polling. And
I
yeah,
wanted
that's
to find,
Fox News does that stuff all the time. I wanted to make him an example rather than be political.
yeah. No, it's funny. I like going to R data is ugly just to see examples of bad visualizations. I wanted to see if I can find one with color, but because the colors, yeah, colors like super important. And just, yeah, we'll see if this one is if they're complaining because of the color. Uh, but yeah, looking at this, like what I would do here, typically your eyes are drawn to kind of these red, orange, yellow colors, and kind of the blue ones are like the quick comparisons between two. But if
And
I was
also
looking at this, like,
because the
yeah, go ahead.
longer the ones that are further out from the center, we get a kind of sense of perspective that almost looks like it's
Yeah,
three-dimensional. And yeah,
true.
and red, the heavy color red and the heavy color you see the reds and the ones above with the really big slices that are like blues and purples. They're similar in value, so they come to the front to us visually and they kind of become more dominant. Whereas like these other colors, and there's very little gradation in those colors between some of the really bright colors. Yeah, it's real bad.
Yeah, honestly, color is also super important, and not only does like drawing the eye to what you actually want to see is like compelling in the visualization. Yeah, so you see like yeah, red, right, is like where the eye is drawn here versus the gray or versus
And
blue.
the red will look like it's forward. If you notice, it looks like it's closer to you
True.
than the gray because that's a it's almost a kind of atmospheric perception. You know, if you look at some classic paintings, things that are bold are really sharp, and then things in the mountains and distance are kind of a softer color.
I've also heard that you shouldn't use green too much under your data visualizations like this, just for like color blind or like color accessibility reasons as well. So there's like some other ideas like this is why typically we use red and blue to compare different data, just because it's also some of the color blindness side. But yeah, if I go to baseball, I'm at a baseball conference, so may as well pull up Baseball Savant while I'm here. Let's see if I can find it. Baseball Savant. I like Baseball Savant gets a lot of love in the baseball community just because of its like data visualization. Oh my God. Apparently it's down or my firewall is blocking it. That's weird.
Is that your
Uh,
Alex?
pardon?
Is that your site?
It's not mine. No, this is like owned and operated by Major League Baseball. But it's like it goes over some of the different yeah, I'm not sure why. I guess my firewall is blocking it for some reason. But basically, it's you'll see that it uses like red and blue. I don't know if I can just get an image. Let me just pull up like Aaron Judge. So let's say maybe it's yeah. Anyway, you can. I want to. It has a really good example of like red and blue, but maybe it's because I'm maybe doing typos. So I can find a good one.
Yeah,
Yeah, here you go. So this is like a common.
I see it
Yeah, there's
flying
like
right
a
there to that site.
Yeah, this is a common like dashboard that you may see coming from the baseball side. So you see that like red typically is like good, draws your eye quick. You don't need to know what any of these stats are, but if you look at this and you're like, oh wow, look at all this red on his page, and sure maybe he whiffs to like that's bad, and we're doing it blue. But you can see that we're using red and blue here to kind of tell that story of like, oh, if he's red, it's hot and he's good at something. If it's blue, he's cooler, cold, worse at something. And so
Mhm.
again, it's using that like color dichotomy to help tell the story without necessarily having to be a domain expert in the space. So a lot of these ideas, I want to just for the sake of time here, come back. This is a lot of concepts around individual visualizations. How do we make one visualization good? How do we make one visualization tell an effective story and describe our data effectively? This then gets compounded when we start using dashboards and using multiple visualizations within a single interface. So this is where there's a lot more like principles around dashboard design. And I actually really like what Karen just mentioned about coming from an art background because it's really compelling. I think telling a story with data does require an artistic lens. It requires some creativity to be able to pull something together into an effective dashboard or into an effective, I guess, communicative tool. So you'll see some of the 5 principles of dashboard design: storytelling, color usage, and then going into the chart selection and the user journey, right? How do you want your user to start interacting with your dashboard? Typically, you have some visualizations at the top, some visualizations at the bottom, and of course, that's all important decisions you have to make as a designer. Of course, you want your most important visualizations, or typically what you'll see is something like this, which is your key metric. So up here we have 804 suppliers, 61% contracted, 39 unlisted. Again, this is also like a donut chart, which is kind of fun. You have your key metrics here at the top, and then some more in-depth more detailed visualizations, more complicated visualizations down at the bottom. Again, we view and read dashboards top to bottom, left to right, or at least in the Western, I guess, just in the West. And so that needs to be how we design our dashboards too. Again, same thing with the colors. Red typically pops out a little bit more. If you're doing comparisons, make sure you don't have colors that are too similar. Again, looking here, I do like how all these bars are pretty distinct individual colors. So choosing that color palette's important. And then I also really like the data to ink ratio here as well. Most of the color on the page is related to data, right? We don't just have a bunch of other excessive information. So as you go through the material in week 6, I want you to start keeping some of these principles in the back of your mind. The principles for creating a good single individual visualization, and then the principles for combining these multiple visualizations into dashboards. Awesome. We'll send some links for just additional reading about dashboard design. I had like a whole textbook on this when I was doing my master's a long time ago, and it was really interesting and compelling to me because typically my background is mostly mathematics, statistics, but I also kind of dabbled in some artistic stuff back in the day. So it was really interesting to kind of see how to design and use like color and things to really help create a compelling story with your information. And again, coming from my baseball experience, when we were interacting with coaches and players and non-technical stakeholders, they don't want to see they don't want to see leaderboards. They don't want to see just a bunch of numbers everywhere. They want to see visualizations so that they can quickly scan and get something actionable from it. And even at my work at Databricks now, we hear similar things with like executives and things. We just want to quickly look at something, quickly use natural language to query something, and just get the information I need to make my decision or to help make a decision as fast and as informed as possible. So dashboards go a long way into that. And now you also have like AI being integrated with your dashboards. At Databricks, we have something called like Genie with AI BI dashboard. Let me see if I can just find a quick link of it. Basically, it's not only do you have a dashboard, but now you can also have like a natural language type of interface in with it as well. So you can start like querying, using natural language to help query your dashboard, right? Use natural language to help generate your leaderboards and visualizations and things. So it's interesting, compelling stuff to kind of see kind of where dashboards are being improved upon. The other big one for this in the space is Tableau Next, which is like next generation Tableau, which is a Salesforce product. And the same type of idea, right? Using AI and agents to help like integrate your dashboards, adding in a semantic text layer, right? Natural language to SQL layer. And again, same thing. How do you go from your data to natural language on that data to visualizing that data, and then finally the whole point of data science, making your actions, right? Making your decisions off of that data. So this idea of visualization going back 200 years is really coming in full circle with kind of the advent of with AI integrations. Um, cool. I'm gonna pivot over. Just 'cause I know we got 10 more minutes before we lose George. So I want to kind of show a couple of the notebooks in the session today. And then if you have to hop off, I'm gonna keep recording and show the dashboarding. So let's start with just kind of our very first lab here. which I'm gonna jump over to 6.2. So with Python and Jupyter Notebooks, or the way that we're creating these visualizations, there's a couple of key libraries that you need to know. The first is matplotlib and Seaborn. Matplotlib is Python's root basic visualization library. You can create anything you want with matplotlib, typically bar plots, area charts, pie charts, donut charts. You can do all of that with matplotlib. Matplotlib's integrated with pandas, so the idea is that you have your pandas data frame, and then you can really easily create visualizations on top of that. We don't need to do 6.2. Let's jump into 6.3 instead. Sorry about that. And then Seaborn is a visualization library on top of Matplotlib, specifically for statistical visualizations. So we did this a couple weeks ago as well, but creating your histograms, creating your box plots, creating your violin charts, those are all the type of statistical charts that you can make with Seaborn. So Matplotlib for your basic plots, your bar plots, your area charts, your donut and pie charts, Seaborn for your statistical charts, your box plots, your density plots, your violin plots, your categorical plots, swarm plots, pair plots, all that good stuff. A lot of really interesting things in Seaborn. So this is a hello world concept. Let's run through this lab right here, and hopefully this all works. But this is our 6.3 is our introduction to matplotlib. And again, hopefully my kernel, oh, look at that. My kernel is live and ready to go. I wanted to show two quick things in this hello world exercise. The first is how easy it is to start connecting matplotlib with data that you may already have prepared in pandas. And then the second is also just on a similar idea as last week, which is garbage in, garbage out. If your data is not ready or clean or like prepared, you still have lots of null values, incorrect data types. It's going to be really difficult to make compelling visualizations from that. So again, the old motto of 80% of a data scientist's life is data cleaning still kind of holds true here as well. Sometimes I view dashboards as and in week one, I talked about data products, and creating these dashboards is just another type of data product, right? So not only are we creating machine learning models, but we also create data dashboards to help communicate our data as well. All right, so with matplotlib, big idea here is that these are static visualizations, as in it creates like a JPEG or a PNG. And matplotlib does your basic visuals. So let's just do a quick line plot here. Notice we're using pandas to identify what subset of data we want to visualize. And then we can actually just connect dot plots, or I use something more like this, which uses the matplotlib engine. I'm going to plot a line chart. I'm going to add a title, and I'm going to add in my X and Y labels. And just like that, we get this beautiful little line chart that connects from matplotlib straight into our pandas I guess plot. A couple more customizations we can do. We can change colors, we can add annotations, all of that good stuff. So here we can see that we've added this little annotation about when the 2010 earthquake was. We can do the same thing if we wanted to pull data from, I'm on my Windows, from China and India, subset the data, and now we can do a multi-plot. This one is not going to work by design just because it pulls all of my years all over the place. What we first need to do is transpose the data and then plot it. And don't get too hung up on the code or the syntax. The biggest issues I hear from people with matplotlib is that it's almost like its own syntax. I feel like every Python library has its own small quirks with having to generate the plots and things. So don't get too hung up with the syntax. Start thinking about the big ideas. The default colors are red and blue here. I kind of like that. Oh no, did we say red and blue? No, I think those are just the default colors. That's fun. Yeah, so anyway, that's kind of the big idea there. And like I said, matplotlib gives you a bunch of basic ones out of the off the cuff. Bar plots, area charts, pie charts, scatter charts are going to be your most used. And then typically I use Seaborn for histograms and box plots and density plots. The other library that I guess I'll do after maybe George hops off is going to be Plotly. Plotly is what we're going to use in the second half of week 6, which is an interactive plotting library. So unlike Matplotlib and Seaborn, which creates static visualizations, Plotly creates an interactive visualization. So you can hover over it, click on it, etc. With interactive visualizations, you need to be able to serve them on the web, right? So you typically need some kind of web hosting solution, whether it's a Jupyter Notebook or something else. But typically you have to deploy these things as web pages or web apps. Otherwise, it's not really interactive, right? If I give you a PDF, you can't really interact with it. But interactive, yeah, old school BI is out. AI BI is the new big thing. With Plotly and interactive visualizations, you can do some really interesting, compelling work. And Plotly does have a free tier, and we're going to be using Dash as well. So we'll go over this a little bit in the second half of the lecture today. But yeah, let me see if I can find some their documentation, I guess. Plotly, while it integrates with Python, also has a couple other integrations. So you can also do, you can integrate it with R, JavaScript. There's a whole bunch of other ones. MATLAB, Julia, all these other languages. You can start interacting with Plotly. But Python is the most popular way to use Plotly, and Dash and stuff. So it's pretty cool. Unless I can spin up like a little. Oh yeah, there we go. So interactive. If I hover over it, it reacts to what I do. I can zoom in and stuff on it as well. So that's what I mean by interactive visualizations. And then the other aspect to interactive visualizations is being able to use filters. I should be able to click on a drop down, select a year or decade or age range, and have my visualizations react to that. So George, I think that's one of the big ideas I wanted to get across there. I'm going to do a couple more coding examples and then I'll close it down. But yeah, feel free to hop off if you need to.
Okay,
Um,
sure. I'll hop off right now. I've got to pick up my kid from school. So, thank you both of you, Alex as and Karen as always, and I'll see you next Monday.
yeah, definitely recommend jumping back to watch the last half of this if you have
100%.
half an hour later. But
100%.
yeah,
Have a good
appreciate you.
day. Have a good day. Good to see you, George.
Thank you. I will do, Alex. Thank you.
Thanks, George. All right, so we've gone over the first kind of hello world with matplotlib. I'm going to keep recording. If you have to hop off at the top of the hour too, that's fine as well. I'm going to show maybe one more. I want to show one more visualization notebook and then the Dash example. That's just the matplotlib. Scatter plots and bubble plots are fun. Maybe we'll do this one, I guess. Well, 6, 7. Line charts, scatter plots. Maybe I'll do this one, histogram, pie charts. Cool. Yeah, this one basically shows everything. Oh, and the subplots. Yeah, that's a good one. All right, I think I'll do 6, 7. I don't care about waffle plots. I don't really care about maps right now. We do folium in week 10, which is should be good. But yeah, all right, I'm gonna do 6, 7 and then 6, 13. All right, and then I'll wrap up the recording. All right, so our next example that we're going to run through is 6.07, which is a good example of all the different types of visualizations that we can do in Matplotlib, as well as making a production-ready static dashboard. Or I guess not a dashboard, but a static data visualization that we can share with our executives. So what we're going to run through again, this is 607, the 6.7 lab. So same kind of data set. We're still looking at that same immigration and data set. I just hope all of my kernel is still alive. Otherwise, I'll have to pivot over to, oh, perfect. All right, so let's grab our data. We're looking at immigration data from the United Nations. I think it's into Canada. Immigration data to Canada. There we go. Cool. When looking at our data frame, we can see we got 195 rows and 39 columns. And our data is already pretty clean for us, which is good. If you did check the data types, all of our data types are solid and there's no missing values. So we can start with a line plot as we did in our Hello World exercise. Here, again, notice that I'm using figure and axis instead of just the figure, as this will come into play later. Typically, when we have multiple visualizations that we want to have together, we need to utilize this idea called subplots. Subplots basically allows us to have multiple plots in one big dashboard or one big chart. So in this case, we only have one subplot, so we could have just used the single plot, but it's still fine. So here we have our little line charts. Notice we can't read our y-axis, and we're going to we're going to cast that to a integer to be able to do that. So looking at this now that we've made it an integer, matplotlib is smart enough to pre-bucket this in what it thinks is the best way to visualize it. And this looks great. So as you can see here, we can quickly just look at it, and immigration has gone up to Canada from the 1980s to now, going from 100,000 to 250,000 in about 40 years, 35 years. And yes, this does start at 0. So this, you can see our ticks are every 50,000. So this is how not to lie with a y-axis. Not only can we plot a graph, we can also customize it. So you can basically customize matplotlib graphs however your heart desires, whether it's with markers or colors. And as we've talked about, it's really compelling to use different colors and marker styles to help contrast and communicate different data in your different patterns in your data. And here we're adding a grid in the background. And let's do a similar thing for Haiti. We're only going to look at data to Canada from Haiti. And if I plot this data, you can see that in 2010, we have this huge spike, I guess not huge, but going from 2,000 to 6,000 immigration to Canada from Haiti in 2010. And of course, we can annotate that as well. Cool. Another graph that we'll look at is a scatter plot. A scatter plot allows us to compare, I guess this is more of a bubble plot. Scatter plots are typically used to compare two numeric variables to look for correlations and patterns. Here we can see that we kind of have this curve going up, and again, our year on the bottom kind of looks pretty funky. So we can clean that up, and this is the much better chart. Again, all we did to clean it up was make sure that matplotlib knew that our years are integers and should be treated as such. And again, looking at this, we do see that same pattern that immigration has gone up over time. And just like anything else, we can change the markers, change the colors, change the size, etc. Bar plots are a categorical data visualization. They allow us to compare numeric number to category. So down here we have India, China, UK, Philippines, Pakistan. These are my categories, and my numeric feature is the number of immigrants from those countries. So because we have one category and one numeric, we can use a bar plot or maybe a donut or pie chart if we wanted to as well. To look at the least number of immigrants coming into Canada. We are just sorting in reverse and then pull on the top 5. So we had 1 immigrant from Palau and 5 immigrants from New Caledonia in our data set. Histogram is a statisticalization A histogram shows density, right? Which buckets or bins are most of my values coming from. Because it's a statistical visualization, I would prefer to use Seaborn for this, but we are using Matplotlib here instead. And again, looking at our density, it looks like most of our immigrants is less than 5,000. There's only a few countries that had more than 5,000 immigrants in our data set. The shape of this data is also right skewed, and maybe it's worth looking at the countries that had 30,000 plus as outliers in our data set. When we start looking at statistical visualizations, we're typically looking at the shape of our data distributions. Let's see, just in 2013, same kind of deal. I guess they've broken out their bins a little bit more. And we can also now look at multiple different countries. So they're looking at specifically Denmark, Norway, and Sweden. Kind of fun. Boop, boop, boop. And again, same thing. We can see we actually had pretty similar immigration patterns from China and India. And I think they messed the title up here, which I fixed in mine. Yeah, just again as a reminder, use if you see any discrepancies or errors in the lab notebooks, always check with mine. Yeah, I upgraded the title there, as mine will be the source of truth. Pie charts. Yeah, good, Karen.
I was just going to say one thing that often has frustrated me when bar charts is when you sort the data and you think you want to go descending, but the chart
Yeah.
then shows ascending. So you kind of have to plot opposite what you're thinking because I guess it kind of reverses it on you. It's just, I forget that and it frustrates me because usually it seems to me make sense to have the biggest to the smallest in a bar chart. Because people often want to see what the biggest value is first.
Absolutely. I think that is that's a very good thing to point out. Pie charts, we can also create those in plot and matplotlib. And again, typically, like I said, the subplots option is typically only used when you have multiple visualizations, which we'll get to in a sec. But no, you can also use matplotlib just as a single viz without having to use this axis function. Again, don't get too hung up on the syntax, but you can draw a pie chart here with matplotlib, and you can also cut out a hole in the middle. I'm pretty sure it might just be whole equals 0.4. No. I'll say axis pie chart
That's too
whole.
easy.
It's something they updated it recently. I swear they updated it to be able to do a whole. Maybe not. Maybe I'm overthinking it. I know back in the day you had to like draw a white circle and then overlay a white circle over it. But maybe let me see what I can do. Donut. I'm not usually on this computer. Donut charts, matplotlib. I could have sworn it was just a whole. They gross. Where is it? No, I guess they didn't do that
V
there
equals
either.
center? No, that wasn't it.
No, that's too complicated. Oh well. Yeah, this is what I had to do back in the day. Draw a circle and then put it over the part. I thought maybe there's an update, maybe not. Maybe I'm thinking of a different library. But anyway, I won't get too bogged down.
Maybe Seaborn.
Yeah,
Seaborn tends to abstract a lot of things from on top of Matplotlib.
yeah. Maybe I was mixing it with Hatch or something. Oh well. I'll leave it as an exercise to the reader to make this a a pie chart, a donut chart. but it's not too bad. We can create another pie chart here using continents. Actually, maybe I will make, let's see if I can make a donut chart just so you have an example of it. I'm pretty sure it's this Geeks for Geeks one that I do. Yeah. Let's see if this will work. If I just shove this down after we draw the pie. Aha, magic. Look at that. We created a little thing. And we can, if you want to make the hole smaller, we can just make that number smaller. So maybe we do 0.5 or something. Cool. All right. Subplots. This is why I mentioned we use subplots. The idea with subplots is that you can have multiple visualizations in one graph. So notice here we have a line chart next to a scatter plot. These are known as subplots within kind of one larger figure. And again, we can specify that by specifying our axes and then using indexing to figure out which axis or which subplot we actually want to plot. So this is great. It's how you can get some more complicated side by side, or even this is a 2x2. Maybe not this one, but I think the next one will be a 2x2 grid. So let's grab it and then execute it because it's pretty cool. And again, big idea here is practicing with Matplotlib and Seaborn to create static visualizations. Yeah, 2x2. So this is a pretty cool looking grid here of kind of everything, which is nice. Of everything kind of we went over in the first half of Unit 6. And if you wanted to add your little... I don't know if I need to add the donut chart, if I should have done this as like axe. Get current figure. Maybe not.
It worked before, so don't break it.
Yeah, I'm just, don't leave it. Yeah, don't break it. Anyway, cool. Last thing I want to go over, and yeah, I gotta hop off in about 10 minutes, so we should be done by then. Is Plotly and Dash. Karen, if you need to
My
hop
ride
too,
is
it's totally fine.
technically in 30 minutes, so.
Okay, nice. Yeah, we'll be done in
Or they
10.
might expand it. That's why I'm not trying again. They've
No,
been
all
asking me to
good.
get down to a few minutes, and I go, "Oh no, it's gonna be another 30 minutes." There's only two vans, and it's on demand.
Gotcha.
And then there's only two minibuses, so they can get really busy and things change. That's the thing I was saying is sometimes if people cancel in between, then all of a sudden they're here in 10 minutes instead of 40 minutes.
Yeah.
Can't really say refuse it because then they get kind of upset.
Last thing I want to go over is just the main lab here, which is 613. This is our practice project. This will use both what we've learned with Matplotlib and then what I'll also review kind of with Dash, which will go, we introduced it in 612, but we're just going to do it straight in 613. If you take my recap video for week 5, I also show how to go over the new UI for using Dash in our lab. You see we have 2 parts here for our big exercise. Womp womp. Something busted. Not on this one though. Oh well. All right, let's just go over here. So this is 13.1. This is the first part of our project. What we need to do here is use Matplotlib, Pandas, Seaborn, and Folium, which also creates maps to create some pretty compelling visualizations. And again, this is real data coming from gathered information of historical wildfires in Australia. So let's grab the data that we've already prepared for you. And luckily, most of it should already be pretty clean. We can do a quick look at the columns, look at the data types, and then knowing me, I want to do a df.info as well. And we can see all of our data types look good. We don't have that many missing values. I don't really care about confidence, but everything else looks pretty good. Date is the only one that we need to change. So we're going to convert that to a date time. and then extract the year and month to be used as other kind of visualization categories. Let's verify the columns again. I'm just going to call df.info here again. And we should see that we have year and month as integers now. Yay. All right. I think most of these give us the solution. So yay, that's to make our life easy. First, let's look at our pandas plot. Or maybe not. Luckily, I did this earlier. Yeah, the solution should load. I'm not sure why this isn't loading up. Anyway, oh, it's my notebook is frozen. Classic. Yeah, there we go. All right, so yeah, there's the solution. Cool. So first we're going to look at this first graph. It's just a line chart of the fire area impacted over time. We can see 2012 was a pretty bad year for the wildfires in Australia. We can see there was a peak between 2010 and 2013. That's what we just called out with 2012. Let's look at the individual year by year. And again, we can just shove that into our cell. And going year by year, we do see kind of a larger spike going into 2011 and 2012 specifically. But yeah, 2012 and 2013 were both pretty bad years. Its peak was after 2011 April and before 2012. So let's look at a bar plot. Let's use Seaborn to be able to create a bar plot comparing, again, categories to a numeric value. Here we're looking at our region compared to fire brightness as our numeric value. Again, you don't really have to use Seaborn for this because it's just a bar plot. But one thing Seaborn does add here is the standard error of the mean, which we talked about in a previous class, which I think is at least worth pointing out. Let's use a pie chart using matplotlib to visualize the vegetation fires. And again, we can see that Northern Territory, is that a thing in Australia? I don't know, whatever the NT region is, versus, yeah, New South Wales and Queensland. I don't know what WA is. We can see quickly compare which are which regions have been hit the most. And going back to what I talked about in the first half of the lecture, comparing the WA pink to the NT orange, it's impossible for us to tell which one is bigger, just how humans look at that. So again, making this a pie chart, or donut chart, or a bar chart would probably be a more compelling visualization.
Actually, the pink looks bigger than the other to
Yeah, it
me
does, right? Yeah,
because
me
of the
too.
difference, because of the way the warmer color.
Yes. Next, it wants us to basically add in a legend. So I'm gonna shove that in here as well. And here's our little legend that we have up here on the top right. Again, we can kind of see we've basically moved the annotations, which is kind of hard to read for these smaller slices, into our legend up here in the top right. They're going to use matplotlib to create a histogram, which honestly is what they should have used Seaborn for. But pretty cool, nice looking normal distribution here, not too many outliers. I actually don't know. Um, Seaborn just the SNS.hist? No, hist plot. Yay. So there's the Seaborn hist plot. Notice it looks a little bit nicer than just the matplotlib one. I also like doing let me do one more. A violin plot. Ooh. Did that work? No. I'll say I probably didn't give it all the parameters that it needed. But I'll leave those in extras for the reader as well. Create your own little violin plots and stuff. We've got a couple more here, so let's shove this in. Oh, now I should have read the next cell. Now we're using Seaborn to do the histogram. And whoa, now we have multiple classes or categories that we're also plotting on top. So we can quickly see some interesting things here that New South Wales definitely seem to have less. And the pink one, I guess that's Washington, definitely seems to have more versus some of these other regions. Very cool. We can now stack them because Seaborn's great, and this will make it a little bit even easier to read. There we go. And so now we can kind of see this pretty interesting graph. This one's a little bit more difficult to actually um, tell as a story, but it's a pretty graph, at least. Next one, we're going to see looking for correlations. Whenever you see correlation, we're going to be comparing two numeric features. Two numeric features means we're going to use a scatter plot. And here's our scatter plot, and my conclusion is no, there is no correlation between these two features. And now we can make a map. So let's create our little map down here as well. Folium is an interactive library, so this will be an interactive visualization within our notebook. Make this notebook trusted. To load map, file, trust notebook. What? I have never seen that before. Yeah, I have no idea how to make that trusted. That's wild. I'm sorry, I haven't seen this one before, but I don't really have time to debug it. You haven't seen this before, have you, Karen?
Yeah, no, I've not seen it before.
All right, so we'll skip over the Folium one for
Yeah,
now,
and you
but
don't
I
well.
promise
I
it
was
works.
gonna say if you have a setup that's not working, I can always share my screen and give you control.
Yeah, it worked on my,
Then you get to use my computer, which should be working for them.
yeah. No, it worked on mine, but I was running mine locally. So you can also try running it in Colab to see if it'll work there. And I'll try and debug that Folium issue um, later when I have some more time tonight. All right, the last thing I want to go over, I know we're already at time, so let's kind of get this wrapped up, is the second half of 6.13, which is creating an interactive dashboard with Plotly. This should be pretty quick. I'm just going to copy over my code. But first I want to go over is what the interface looks like. So when we start coding with Dash, as you'll see if you read the documentation for Plotly and specifically Plotly Dash, it needs to be run as like a Python application. And when we start writing Python applications, right, we're gonna run them as in a flat file, in a .py file. So if you look at the Dash documentation, you'll see that it wants us to run .py files as like an app.py or something. That is different than a notebook. A notebook is a interactive Jupyter notebook that we can write Python in. So we have a second user interface here within our skills lab that allows us to write those flat Python files where we can run apps like Dash. So if you have experience with VS Code or Cursor, it's going to look very similar to that. So if I click through, it'll tell us a couple things on how to interact with this, right? And how we're going to create our dashboard. But some things first to know, to run a terminal, we're going to click on terminal here and then open up new terminal. This opens up a new terminal down here at the bottom. I like to make my little editor. The editor is this part on the right. I like to make this a little bit bigger. And here we can install our libraries that we need. There's some differences. It uses Python 3.11 and some, and Python 3.8 and others. Luckily, it doesn't really matter for our use case, but know that in practice, 3.11 is the more modern Python version and should be used more often. So we've opened up our terminal. I'm installing these commands. And again, this is running in my cloud lab environment. But I personally ran this on my local in VS Code. But that's also out of scope.
Just add that the difference there is when you're using Dash Plotly, It's actually built on top of Flask, which is a lightweight web
Yeah.
server. So what you're actually doing is creating a server, and then you'll view it on your browser on your local host. So it's actually building a web application.
Yep. That's a great point to call out.
And interestingly enough, Dash also, when it creates the plots and stuff, it doesn't make an image, it actually makes JavaScript.
Yep. And that's
It's
why we
actually,
talked about how interactive visualizations need a web interface to run on and run in. All
yeah,
right, now that we've installed our terminal and run the app there, the second part is going to be creating our file. We're going to click on this two pieces of paper icon, this Explorer icon. From there, we're going to click on this first icon, just the one sheet of paper with a plus. That's the new file icon. And 612 walks through how to do this as well. We'll call this -wildfire.py. And now I have my py file where I can create my web application. If you just skip to the end, I'm not going to go over again. The syntax isn't too critical here. But if you go through the app at the lab, it'll walk you through how to kind of add all this code to your file. And at the very end, it gives you the full code here. So I'm just going to copy this full code and shove it over here. So some things to call out in the code is I think I'll just grab the one from my GitHub. That was a lot more clean. Boop, boop, boop. Yeah, it's about 100 lines of code here. This is the same. I just cleaned it up in my GitHub. So what we have here, first thing we're doing is loading in our imports, which is going to be Dash and Plotly. We define the app that we want to build, and now we get the fun stuff. Similar things we were doing in the notebook, read in our data sets, fix our data types for month and year, and now comes our layout. So this is going to be the layout of our dashboard from top to bottom. So at the top of our dashboard, the first thing we're going to have is a header that's set, or a header 1 from your web scraping days, if you remember week 2 or week 3, whatever it was. So we're going to have our first header, Australia Wildfire Dashboard. Here is a style for it, font size, color. Then we're going to have a filter. So we're going to have this radio button where you can select which of these regions you want to query, if any or all. Western Australia, Northern Territory, New South Wales. There we go. Next, we have a drop down to select the year. So we have two filters. We have both a region filter and a year filter. And then we're going to have two plots in our dashboard. So these are kind of placeholders for our two plots. We have a callback function. Basically, this is a listener. When you interact with the filter, that triggers this callback function, right? The input is going to be the filter that you interacted with, and the outputs will be the plots that get generated. So this is a listener to our filters. That's what the callback function means. And here we can see the code to create our visuals. First, we filter our data by region. Then we filter our data by year. Then we aggregate our data by month and calculate the average. Then we create our pie chart. Then plot 2, we aggregate by month and count, take the average again. Or did we aggregate just by month and then take the average? And then we create a bar chart. And then we finally return plot 1 and plot 2. So in total, we should hopefully have a header, a couple of filters, and then two graphs that should be side by side. To run the code, it's a little bit funky. We have to click on our special skills network lab icon. And then from there, we can click on this launch application button. And then when we do that, our application port is going to be 8050, 8050, which is in the screenshot. And if I run this, this should hopefully work. Oh, I guess I didn't run it. Oh, I forgot to run the command. Run the command to run the app. Boom. Yay, app is running. And now we can go to here, launch application 8050. And we should be able to see our dashboard. Yay. Title, filter 1, filter 2, pie chart, and where's my bar chart? There's my bar chart. Pretty cool. And we can even open this in a new tab if we wanted to, which is kind of fun. And since we have this callback function, it should be interactive. Obviously, the graphs are interactive. But if I click on Queensland, you'll notice that both my graphs update. And if we go to like 2012, which was the big year, all my graphs update as well. We can see the fires were in November and December. So, question, why are there fires in November and December in Australia? Isn't that winter? No, it's the flip, right? So, November and December is the summer in Australia. So, hot and lots of fires raging there. Cool. And that ends your kind of week 6 final project. Notice we created both a static dashboard visualization by using all of our different matplotlib functions and seaborn functions. And then we also created an interactive web application using Plotly and Dash as well. Big ideas I want you to take away. For individual images, think about the best practices for data visualization, data to ink ratio, your use of colors, your use of chart junk if you have any, right? What makes data beautiful? What makes data ugly? Think about different ways you can lie with graphs and your y-axes. Then start thinking about dashboard design as we start adding in more functionality, more usage, more visualizations, more filters. Think about best ways of laying out that information to make it usable for your users. And if you want to go a little bit further, now you can start adding in AI into this, adding chatbots, natural language models and things that can start taking what you say in language and using that as filters against your dashboards, right? AI in your BI, right? BI business intelligence for your dashboards. Um, yeah, I think that's it. Last thing I'll just mention is again, this creation of dashboarding and visualizations. This again is known as data products or data apps. These are outputs that data scientists should be able to create in addition to modeling, right? And models. And usually there's some mix and match, right? When we create a model, we create visualizations to understand our data. And when we finish our model, sometimes we want those predictions to be graphed, right? I want the expected number of home runs to be a bar chart on a player report or something. So there's a lot of overlap between them. But as data scientists, we should be expected to be able to do predictive modeling as well as data visualizations and dashboard design. So when I do my recap in forums later, I'll be sure to post a whole bunch of links. Definitely, again, big in things to me, dashboard design principles, Edward Tufte's visualization principles, and then what does it mean to be an interactive visualization versus a static visualization? And what are the pros and cons of each? And then also the future of BI with kind of AI capabilities as well. I think that's all I got. Karen, missing anything? All good? Out of here. Awesome. Yeah, recording's going again. Yeah, so we're just gonna wrap up there. Thanks for joining. Thanks for watching wherever you are, and thanks for the engagement in the forums this week. It's good to kind of see that. There's only one discussion forum for week 6, so no excuse to try to not participate in it. Just shoot a quick your quick thoughts over there, and Karen and I will respond. All right. Thanks, everyone. Please reach out if you have any questions or
And we love
concerns.
company.
Yeah. Thanks to those that have shown
We
up.
can't promise actual cookies, but we like company.
Absolutely. All right. Have a great rest of your week, and we'll see y'all in the forums and online next week. Thanks, everyone. Take care.